Assalamualaikum and hello everyone. So today I will be presenting our study on the relationship between daily caffeine consumption and sleep duration among 30 university students. As we know, due to intense academic pressure, many students rely heavily on caffeine like coffee, energy drinks or tea just to stay awake. However, this inadvertently disrupts their natural sleep cycles, leading to long-term health risks like anxiety and sleep deprivation. To address this issue, this study utilized descriptive statistics, visual graphic, Pearson correlation, and simple linear regression to analyze these lifestyle patterns and determine how accurately daily caffeine intake can predict total sleeping hours. To guide our investigation, we established three main objectives. First, to observe the distribution pattern of caffeine consumption and sleeping duration data using descriptive statistics and graphics. Second, to determine the strength and direction of these two relationships between these two variables using Pearson correlation. And third, to evaluate the exact effect of caffeine consumption on the sleeping duration of university students using simple linear regression. For this part, why is this study significant? For students, it aims to raise awareness about how excessive caffeine impact well-being, empowering them to make healthier lifestyle choices. Second, for campus administrators and medical professionals, these findings serve as a practical guide to design educational campaigns that promote proper sleep hygiene. And lastly, for the academic community, this investigation provides a foundational statistical framework and a valuable reference for future researchers exploring the impact of daily habits on student health. So, we must keep two main limitations in mind. First, our data relies entirely on self-reported questionnaires, which are prone to memory errors or inaccurate reporting. Second, our simple linear regression only examines the direct impact of caffeine, overlooking other influential external factors like academic stress, screen time, or exercise. Nevertheless, this framework sets a strong baseline. Now, let's dive straight into our data distribution and the visual graphics we obtained.
Assalamualaikum warahmatullahi wabarakatuh. To saya Saiful, and this is my part about methodology. So methodology is a method we use to find our result based on our collected data in this study. So in our study here, we use a quantitative research approach where primary data collected using an online questionnaire through Google Form. A total of 30 university students are participated in this study using convenience sampling, and the duration of collected data we collect about 1 week. We go through to the next part, which is data description. What the purpose of this part? This part is to determine the relationship between caffeine consumption and sleeping duration. The study consists of two quantitative variables. The independent variable is daily caffeine consumption measured in cups per day. Meanwhile, the other one is dependent variable, which is dependent variable is sleeping duration that measured in hours per night. These variables were selected to investigate whether caffeine consumption is associated with sleeping duration. What kind of graphical techniques we use to examine and observe our data? In our study here, we use three kinds of graphical techniques. First one, histogram we use to display the frequency distribution of each variable. The second one, we also use box plot to identify outliers and observe the spread of the data. The last one, we use scatter plot to examine the relationship between caffeine consumption and sleeping duration before conducting further statistical analysis. This is the last part of methodology, is numerical techniques. Descriptive statistics such as mean to determine average, median to identify the middle value, standard deviation to measure how much the respondent's caffeine consumption and sleeping duration vary from the average, and variance to determine overall variable. We used to summarize the data, and there are two important parts here, which is Pearson correlation and a simple linear regression, where Pearson correlation was applied to measure the strength and direction of the relationship between the two variables, while simple linear regression we used to predict sleeping duration based on daily caffeine consumption.
Assalamualaikum and hello everyone. So moving on, result and discussion, I will start with the data presentation. First, let's look at the independent variable, which is daily caffeine consumption among 30 university students. So based on the data, the mean caffeine consumption is 1.97 cups per day with a standard deviation of 1.497. As you can see in figure 1.1, the 2 cups per day is the most common amount with 8 students. There are also 6 students who do not consume caffeine and 6 students who drink only 1 cup per day. As caffeine consumption increases, the number of students becomes smaller. And then 5 students drink 3 cups, 3 students drink 4 cups, and only 2 students drink 5 cups per day. So overall, this result shows that most students have low to moderate caffeine consumption, while only a few students consume high amount of caffeine daily. Now let's look at the dependent variable, which is student sleeping duration. Based on the data from 13 university students, the mean sleeping duration is 6.4 hours with a standard deviation is 1.155. As shown in figure 1.2, the most common sleeping duration is 7 hours, reported by 6 students. We can also see that 4 students sleep for 5.5 hours, another 4 students sleep for 6 hours, and 4 students sleep for 6.5 hours. For longer sleep duration, 3 students sleep for 7.5 hours, and another 3 students sleep for 8 hours. Only 1 student sleep for 4 hours and 1 student sleep for 8.5 hours, making this the least common sleeping duration. So overall, this result show that most students sleep between 5.5 and 7.5 hours per night, although a few students sleep much less or much more than the average. Now let's start by looking at our data on caffeine. We survey a sample size of 30 student respondents. On average, a student consumes about 1.97 cups of caffeine daily. Both our median and mode sit perfectly at 2 cups, indicating that 2 cups a day is the most typical habit among the group. So if we look at the spread of our data, we have a standard deviation of 1.5 and variance of 2.24. The total range span 5 cups, meaning our heaviest caffeine consumer drink 5 cups more than someone who drink none. So looking at the box plot on the slide, we can clearly see the distribution. The first quarter stand at 1 cup and the third quarter reach up to 3 cups. So overall, the distribution of our daily caffeine consumption is approximately symmetrical with only a very slight skew to the positive. Next, let's move on to our finding regarding the sleeping duration of this 30 student. The data show that the average student gets about 6.4 hours of sleep per night. The median value is slightly higher at 6.5 hours, while our mode is 7 hours, meaning 7 hours of sleep was the most frequently reported duration. In terms of data variation, the standard deviation is 1.16 with a variance of 1.33. So the overall range of sleeping duration spans 4.5 hours between the students who get the least sleep and those who get the most. As we analyze the box plot for sleep duration, the first quartile sit at 5.5 hours and the third quartile goes up to 7.12 hours. Unlike our caffeine data, the distribution for sleeping duration is skewed to the left. Now let's start by looking at our data on caffeine. We survey a sample size of 30 student respondents. On average, a student consumes about 1.97 cups of caffeine daily. Both our median and mode sit perfectly daily at 2 cups, indicating that 2 cups a day is the most ethical habit among the group. So if you look at the spread of our data, we have a standard deviation of 1.5 and variance of 2.24. The total range spans 5 cups, meaning our heaviest caffeine consumer drink 5 cups more than someone who drink none. So looking at the box plot on the slide, we can clearly see the distribution. The first quarter stand at 1 cup and the third quarter reach 2-3 cups. So overall, the distribution of our daily caffeine consumption is approximately symmetrical, with only a very slight skew to the positive. Next, let's move on to our finding regarding the sleeping duration of this 1030 student. The data show that the average student gets about 6.4 hours of sleep per night. The median value is slightly higher at 6.5 hours, while our mode is 7 hours. Meaning 7 hours of sleep was the most frequently reported duration. In terms of data variation, the standard deviation is 1.16 with a variance of 1.33. So the overall range of sleeping duration spans 4.5 hours between the student who get the less sleep and those who get the most. As we analyze the box plot for sleep duration, the first quartile sit at 5.5 hours and the third quartile goes up to 7.12 hours. Unlike our caffeine data, the distribution for sleeping duration is skewed to the left. So next, moving into correlation and regulation analysis to investigate the exact relationship between our independent variable, which is daily caffeine consumption, and our dependent variable, which is student sleeping duration. So our sketches plot usually validate a linear model, showing that as caffeine intake increase, sleep hour sharply decline. So this is mathematically supported by our Pearson correlation coefficient of negative 0.78, indicating a strong inversely relationship where caffeine acts as a central nervous system stimulant that actively describes sleep. Furthermore, our simple linear regression analysis yield a coefficient of determination R square of 60.84%, proving that over 60% of the variance in university students' sleep hour can be directly predicted by their daily caffeine intake.
In conclusion, this study successfully achieved its objective by investigating the relationship between caffeine consumption and sleeping duration. The findings indicate that higher caffeine consumption is associated with shorter sleeping duration. Therefore, students should be more aware of their caffeine intake to maintain better sleeping quality, health, and academic performance. In addition, this study can serve as a useful reference for future research related to student lifestyle and health behavior.
So finally, based on our findings, we have 4 recommendations. First, for university students, we highly recommend promoting healthy sleep hygiene, since many students are pulling down the sleep average. Learning how to balance caffeine intake and rest is essential. Second, for campus administrator, we suggest launching educational campaign. This can help raise awareness about how excessive daily caffeine can impact sleep quality. Third, for future researcher, we recommend expanding the sample size. Surveying more than 30 students will give us a much more accurate and complete picture. And lastly, we also recommend that future researchers include confounding variables. Looking at factors like academic stress or study hours will help us better understand the true relationship between caffeine and sleep